Okay, hello everyone. Thank you for joining us today at MedTech UCL for this term's final event in our Women in MedTech series. I'm very excited to welcome our speaker today, Dr. Islem Rekik. Dr. Rekik is an assistant professor at Istanbul Technical University and director of the Brain Signal Research and Analysis Laboratory. Her research looks at the application of machine learning and computer vision techniques to neuroimaging, with a recent focus on analysis of connectivity. For any students interested in research in this field, there's a few opportunities I'd like to share before we begin. We have a great PhD program here at UCL for medical imaging called Eye for Health, details of which can be found from the link at the bottom right on the screen. Dr. Rekik's lab have also recently launched their own mentorship program. Details can be found from the site at the top right, and I believe she'll go into more detail about this later. And without taking up any more of your time, I'd like to pass over to our speaker today. Thank you for joining us, Dr. Islem Rekik.
Thank you very much. It's really a great delight and pleasure to be with all of you today. So let me just get my screen sharing. All right. So I guess you can see my slides, right?
Yeah.
Okay, wonderful. So today I would like to take you first on a little journey, and that journey starts with my academic travels. So who I am, maybe many of you don't know that. So let me briefly introduce myself. I got my bachelor degree from Tunisia, and then I moved to France where I did my undergrad in computer science for 3 years, followed by a master at École Normale Supérieure in machine learning and computer vision. After that, I moved to Edinburgh, the University of Edinburgh. I completed my PhD in 3 years, and during that time, I got to visit 2 outstanding universities, Stanford and also Johns Hopkins. Following that, I got my postdoc for 2 years at the University of North Carolina, and then moved to the University of Dundee as assistant professor. So that was between 2016 and 2018. Starting from 2018, I moved to Istanbul Technical University, and this is where I am right now, and it's 8 p.m. here. So this is just a big overview. Now, as scientists or researchers, we always start from sites, what we can observe, what we can see, something we can describe, quantify, and this is what we call data. But while data is so important, deriving meaning from data, explaining the data, interpreting the data is fundamental to improve our understanding of the world we live in. So this is what we call, like generally when you guys write papers, you say, this gives us insights into. So deriving insights from the data is so important. And this is what metadata is about. Metadata is actually the data that explains the data, right? So this was how I got the name for my research lab, which I started in 2017. So BASIRA literally means in English, what translated from Arabic to English, it means insight. So the journey started in 2017 and was so exciting for the last, over the last 3 years. I got to travel to conferences with, like my students, do great research, drink a lot of coffee, definitely. And there was a lot of ups and downs that I will share with you during my journey today. I will share a few secrets, let you in on them. So just since we are all scientists here, and I am sure all of us are data lovers, so let's get started from the data. And I'm going to give you just an overview of the BASIRA lab achievements in terms of stats and in numbers. So starting from 2017, over the last 3 years, I have supervised more than 40 students with more than 65 research publications, high impact publications. We co-organized conference workshops and several independent proceedings. Currently, we have 5 international mentors at BASIRA Lab. So basically mentors, they co-mentor or co-supervise undergrad students. And these could be PhDs or also graduate students. We have collaborators all over the world from 10 international institutions in Tunisia, USA, UK, China. over the last 3 years, we got 8 awards, or exactly 14 orals in particularly at MICAI workshops and main MICAI, including also other conferences such as ATSIP, co-organized different events, workshops, and conferences such as Women in MICAI, Progress, Prime workshop, CNI, connectomics and neuroimaging, the FAIR workshop, which we started this year, and the RISE initiative, including among others. So for just the last 2 years, we secured €500,000 funding, and that was primarily from the Turkish funding, TÜBİTAK funding, and in addition to the Marie Curie Fellowship that I got last year. So as you guys can see, we have also a global international visibility with more than 20K visits from all the corners of the world. Now, in terms of research outcomes, we have a YouTube channel, so feel free to look at the YouTube channel. We have about more than 1 million minute views according to YouTube stats. Most importantly, we have 21 paper presentations. These are published in journals or like different class A1 conferences, including MICAI. And also we have a playlist for GitHub Codes demo. So if you want to run the code, you can easily watch the video, see what kind of packages you need to install, how to run the demo, etc. For the last year in 2020, we uploaded 28 GitHub codes to promote open science, so you can access those codes and also you can test them. And we got featured in different venues, including, for example, RCIP, MICAI interviews, ITU news, etc. And these are like mostly about the work we do at BASIRA Lab. So more now about lab members and publications. So since 2017, we had 42 researchers. And as you guys can see, most of them, about half, like more than half, they are at the undergraduate level. And all of those have published works. And interestingly, I did not mean it to be, I always encourage gender balance, but we have an exact balance between male and female researchers at the lab currently. And for the last year, we got 25 publications. These were primarily focused on the field of predictive intelligence in medicine. So I'll talk about this later on a bit. And also integrational network neuroscience. This is something that we introduced to the field in the last 2 years, among other applications such as computer-aided diagnosis, etc. So that was the data. Now, the most important thing about those numbers is not the numbers themselves, but every single number has a story to tell and a bunch of rising stars to reveal, which means, there are like little heroes and big heroes behind those stats. And I would say also that every single plot has different meanings that we can derive and reflect on. So from that, we can move now to the metadata. And this is actually the data that explains all these stats. So I will give you some insights into the why and the how. My RISE experience from the roots up to the shoots. So let's get started from the roots. So I was born in Tunisia, in a city called Sousse, and this is by the East Coast. And growing up, I really loved watching sunrises. This was a video that I've taken in 2018. And every morning I saw this little boat crossing the sun, literally going through the sun around 5:30 in the morning. And as I grew up loving watching sunrises, I always grew up loving hearing about the stories of rising suns. And this includes the story of a young Muslim woman who was born in the 9th century, and her name was Fatima Fihri. So Fatima was born in a city of Qayrawan, and this is a city in Tunisia. So she grew up there. Then she moved with her family to Fes, a city in Morocco. And after that, basically she got married there. And after a few years, her dad and her husband passed away, but they left her with a lot of money. And if you guys had a lot of wealth right now, what would you do with that? If you think for a second. What Fatima did, basically, she decided to build a mosque. And in this mosque, she included a huge library with a lot of books to attract people, to encourage people basically to seek knowledge, right? So this mosque was a hub for knowledge seekers, for scholars from all over the world, and it was called the Qarawiyyin Mosque. So at the time, this was like became a big hub, and now this mosque is actually in the book. It's in the book of the Guinness World Records for being the first and the oldest university to ever exist. So listening to this story actually inspired me a lot. I found in Fatima this young woman, a woman of inspiration, of leadership, of perseverance. And I thought to myself, if she can do it, like 12 centuries ago, like do this colossal work, and like build this university, definitely I can do something tinier or at that level, maybe, hopefully. So that inspired me a lot. And also growing up as a Muslim, as you guys might see from my outlook, I always got my love for knowledge got inspired and emphasized, nourished by the Quran, a book with chapter titles spanning the cosmos, including the sun, the moon, the stars, and going down to earth, including bees, ants, and spider. So this holy book, starting with the word read, it encouraged me to read. I've always had this thirst, for reading that it never got satiated, even now. And it instilled in me the aspiration to increase myself in beneficial knowledge. So where to start? I started with books. So this is the first thing that I want to share with you. Books are so important. They were building blocks of my journey. So if you guys don't have experts, it depends where you were born. You might have, great minds around you, but some students might not, are more fortunate than others. However, nowadays, most of us have access to books. And these books, like they are actually living minds on the shelves. They're not just, a bunch of papers that you leaf through. So when I started reading, I devoured books. I read books about neuroscience, about brains, about self-help, about, female leadership, about stylish academic writing. This is one of my favorite books I completed. I read it during my PhD when I started my PhD. So I read a lot, and I really encourage all of you guys to read, because reading is so empowering and it gives you access to brilliant minds that might inspire you in ways you never have thought about before. So starting with books, books are great experts, but if you find a real human being, like a supervisor, a teacher, a friend, a colleague, a fellow, who can inspire you directly, explain to you things, it simplify things to you, that is a true shortcut in your career development. And I consider myself amongst the fortunate ones. When I met my postdoc supervisor, Professor Dingakshen at the University of North Carolina, I spent 2 years there, and these 2 years were transformative in my life and my career development. Like I would say career rise or boost. So I still remember during that time, we had every Thursday, we had actually different group meetings. We have like journal club, like group meetings. Every Thursday we had this group meeting. Around 40 students will be packed in a room, and we take turns in presenting our work. So I remember when I started my postdoc, I would walk into the room, sit there, start taking notes, and I was exposed to different concepts in machine learning, medical data analysis, registration, segmentation, sparsity, multitask learning, all these cool concepts that I didn't know before, and I was so excited to learn. So what I did every Monday, after I attended the meeting on Thursday, I would not open my notes. And the first thing I do in the morning every Monday is to open my LaTeX file, and I will just, type in what I remember. And this is what we call retrieval. It is so good to improve your learning. So I started, just saying, okay, this was a great talk. This is what I remember. Sometimes I remember a lot. Other times I remember just a few things here and there. But by the end, or around the mid of the second year of my postdoc, I had attended more than 200 talks, and I had a PDF with more than 200 pages with all the notes that I've taken from different projects, different research works published, in top conferences, top journals. And it was so exciting for me, because this process of, thinking and, putting things together, like, reflecting on the content, not just attending passively, just, you're engaging, you're constantly thinking. It made me remember those concepts, and also it inspired me new ways of connecting them. So this is one of the books that I read at the time, and I really also recommend that you guys read it all. It's called Make It Stick: The Science of Successful Learning. So it talks about, retrieval in terms of, learning strategies, interleaving, and also reflection, which is very important. So from there, I was okay. Now I had lots of ideas. My brain was burning with ideas, with, new projects I wanted to chart out. So it was like literally everywhere, projects that I wanted to design, I wanted to develop. I had, new ideas in different fields. And in addition to that, I definitely had a strong passion for my work, for my research, for things I wanted to do, and particularly for the brain. As you know, like, mostly our works at BASIRA Lab revolve around, the brain, but definitely not restricted to that. So I was thinking, okay, you have a creative way, creative ideas, I would say, plus a strong passion. Is that enough to, start your lab, to build your research team and become independent? Is this enough for me? Can I just do it with only those two components? And this was the right question at the right timing, because at the time I got accepted as assistant professor at the University of Dundee in 2016. So I moved there and I thought, okay, now it's time for me not just to talk the talk, but to walk the walk. So basically, you guys, most of you maybe know that when you do research, when you want to become independent and lead and start your own lab, you need two fundamental things. You need many things, but these are the two fundamental ones. The funding, you need money, and you need also research data to do your research, right? So in the beginning, I was, okay, I need to get funding. This is the conventional way that we were taught, passed on, from generation to generation of scientists. You need to write grants. When you write grants, you get funding. When you get funding, you can, fund your research and do your research and publish and go to conferences, etc., etc. So this was the way that I was, this was the only way that I thought at the time was possible for me to start my own lab and, train students and mentor and publish. So what I did in the first year, I wrote so many grants, as many grants as I could at the time. So I applied for ARUK, I applied for CRUK, I applied for EPSRC, and I did not miss out the MRC. So you guys can see probably, these are like the most common funding schemes in the UK. So I tapped into each one of them. And I thought, okay, these were, like, I submitted different proposals. Now I'm waiting. Definitely, I'm going to get at least, one. Hopefully, I will get all of them, and I'll start different projects and, recruit different students. So the outcome was like this. First, rejected. Second, rejected. And the two last ones, you guys might guess, well, rejected. So by that time, I was literally devastated. And some of the comments of the jury members were good. Others were just, very shallow. And you guys know, when you submit also journal papers or even into conferences, you don't always get some good scientific criticism that help you improve and propels you forward. So this is one of the main, limitations of things, challenges, I would say, that you would face when submitting your research and your proposals later on. So anyways, at that time, I was devastated. I was like, okay, what should I do? This is, maybe it's a sign for me. Should I change plans? So like, what about plan B? So I thought about another plan. So back in 2014, I started journaling, so writing a diary. So, like just writing an essays, self-reflective essays. And at the time, I remember after this rejection, I started writing an essay, and I was thinking, okay, I have a plan B, and it's the best plan ever. This is my dream. So I'm going to quit my job. And I'm done with research. I'm giving up my research job, all of, my big tiring dreams constrained by deadlines and competition and high requirements. So I need to free myself. I want to be a free being. I need to free myself from this demanding research path that at the end of the journey is more likely to remain unnoticed for decades to come, or maybe forever. So your work is going to sink into nullness. Okay. So, and then that was I started thinking in that direction. And I tell you guys, your thoughts are the vehicle of who you are. You are what you believe in. And at the time, the good thing about the writing process generally is that when you start writing, you figure yourself out through the writing. So by the end of this essay, I said, okay, if the human nature was coded in a way to easily and frequently get trapped into negativity and depression, the human civilization would not have progressed with such tremendous strides. So I went back to, I have a clear vision, relatively clear at the time. So I know what I truly want. I want to have my own research lab, teach students not only scientific stuff, but how to conduct research and optimize their path of learning. I want to teach them how to, learn how to learn, basically. And this is, you guys might know, this is what we call meta learning nowadays in machine learning. So learn, implement, solidify, learn. And I said, I need to be stubborn. I'm not giving up on my dream, and I'm going through with it. I'm going with another plan. So I need to figure it out. I need a plan C. So maybe this is not the only way, right? So that's what I thought. This question popped into my mind. Do I really need money to do research, train students, and publish? Maybe there is another way. So I thought, yeah, there might be another way. So what do I have right now? I have whatever I have in my hand, I should start using. I have brain, I have intellect, I have passion, I have ideas. I just need to find students and start working together and doing things together, remote students, virtual students, wherever they come from. I just want students who are eager to learn, to join this journey, and we create, cool things together. So that's all that I wanted at the time. So the first thing I think, I'm going to share a few tips here. The first thing I think is most important is that you know your destination. You know where you want to get. Because if you're not where you're going, you ain't going anywhere. So basically, it's important to know your path, your starting point. I'm right here right now. I have a clear vision. I want to build a lab. I want just to train students. Keep it simple. I want to publish one single paper as a supervisor, first time. Okay. I want to find one student to do that. That's it, with and enjoy publishing and working together. And this is what I actually did. So having a sense of purpose and directionality is so important, to achieve your vision and to develop your vision. Now, also starting with your why. Even if you guys now are master's students, undergrad students, you are PhD students, or you're leading labs, whatever you're doing, you always need to ask yourself, and I think it's a very important question, why you are doing this, why you are attending this seminar, why you are listening to me right now, why you're doing research, why you want to publish. So it's so important to answer your why, because your why is your roots. It presents your roots. And when you are well rooted, you can shoot higher. So it's so important to have that. And what I was thinking, I always kept in mind, okay, I want to do this because of this and that, because I want to. So it's very important to know your why. And then even you guys know, when we submit papers at Mikai, so I'm also reviewing for Mikai and an area chair, the first thing that the reviewers say, what is your rationale? What is your hypothesis? Why you are doing this? Why you're using this method and not the other method? Why you are proposing this loss function and not using another one, for example? So even when you're writing a scientific paper, knowing your why is very important. Now, also another thing, you don't actually need to take permission from people around you to lead. When you want to lead and do something of your own, just do it. Don't overthink. Don't wait for anyone to give you permission. So let's say, for example, my PhD, my students, I always encourage them to work on side projects. So even if they work on side projects with other, with other colleagues or other, teams, it's okay. As long as they are implementing their work with me, they're like, we're developing the project, it's going smoothly, it's nice. You have your free time. You own your free time. You can do whatever you want with it. Okay. So it's important to expand yourself in different directions, explore new things, new ways of thinking, try, for example, even if you are a PhD student, it's so nice to start co-supervising. Why not? Right. And then you learn how to guide, and you gain more confidence, and you test your ideas, and you enjoy the process. So building that confidence and having that in you is very important. And I believe every single one of us right now has something to teach and to share. I'm sure all of us do. So you just need to have the confidence to, and also the skills a little bit, how I'm going to do it, how I'm going to share it. Okay, so just keep thinking about it, and then you'll see the path. You will see it. You'll gain clarity. So another thing, so developing your ideas and defining your project. So I love, to circle my projects, create, a vision. What is the idea? So these were, for example, projects that I proposed last year. Many of them got published and accepted in conferences at MICAI last year too. So basically, you might have different ideas. It's important to read papers, know the state of the art, diversify your reading, and then every single cool idea you spot out, write it down, but also write why it is a cool idea, why this model is cool. Why this, maybe you're introducing a new concept. No one has solved this problem before. Maybe you are introducing a new problem to solve. Why this is a cool problem to solve, or an interesting problem to solve in the first place in the medical field, for example, or an AI. So next, envisioning the project development trajectory. So I always say, if you don't see, as I said, you don't need to see the whole trajectory, A, B, C, D, etc., everything about the method that you want to develop, but you need to know the problem you're solving. So for example, I'm working on segmentation or registration or prediction or classification, and I want to, for example, segment stroke lesions. I want to work, for example, on heart modeling, or segmentation, or registration, hard data registration, cardiac data registration. So you need to know what is the project, where you start, and where you want to get at. Now the trajectory will unfold. You will get lots of ideas, and then you will start filtering them out, and you will get a clear understanding of what you want to implement. So to be honest with you, I always have a trajectory in my mind, but it's not always the way it unfolds over time. But having a preliminary path and approximation for your optimization is always good. And you guys know that, and also in machine learning. So this is, for example, here. This is, I had a meeting with one of my students, and I just charted out the unfolding of the project. And it was really cool to have that. Even, the student got excited. So, okay, we're going to do this, that, and that, why this is important. What are the benchmarks? What are the comparison methods? We're trying to integrate this idea, why this idea is important to do in the first place. How can we go about, for example, implementing it, et cetera, et cetera. So also, this is the D squared that I love: deadlines and deliverables. So this was the plan, for example, I shared with my students last year about MICAI 2020. So it's always nice to have deadlines to set, whenever, for me, a deadline is a motivation, just keeps me going, keeps me rolling. So having deadlines set and knowing your deliverable on a weekly basis, for example, or even monthly basis, or big deadlines such as conferences, having that in your calendar is important, and keeping track of your milestones. I think it's a good habit to have, and it helps you to optimize your time and also increase your productivity. So, and last, I would say, finding students who are eager to learn, who are true seekers. They seek, to learn how to do research. I don't care if the student who comes to me has done, how do I say, has great skills or not. The most important thing, if they have basic skills like, Python programming, some basic knowledge about machine learning, then we can even dive and start working about, on cool cutting edge research projects such as, graph neural networks. As long as they are eager to learn and they are disciplined, they are engaged, it doesn't matter where they start from. The most important thing, I believe, in a learner, and I'm still a learner myself, is the momentum you can build over time, the speed at which you can wrap your mind around concepts and things. So as I say, in general, like every single learner is an untapped potential. And if you don't tap into it, it will remain a wasted talent. And we don't want to waste talents. We want to transform people one at a time, one human being at a time, one brain at a time. So this was basically the way I did it. I started finding students, I started publishing, and I thought, okay, I don't need actually funding. I can publish in journals without funding if I don't request open access and they don't require fees, publication fees. And I targeted those journals, and including medical image analysis, neuroimage, pattern recognition, and these are high impact journals. So I would say whenever the road gets blocked, you need to think that there's an infinite number of blocks that will rise up to meet you. Like, it's not the only possible way. There are many possible ways around. You just need to think differently. Just never give up and keep going, keep rolling. And this is a proof here. So this data, these publications that we got in 2018. So I started my lab in 2017. In 2018, we got 27 publications in both conference and workshop proceedings, primarily MICAI and other conferences like ISPI. And also journals. So these all were without, so at the time, basically, I did not have any grants, okay? So now, going back to the equation, I think you guys know the answer. So if you have ideas, you have projects, you know how you're gonna do that, a little bit, not too much. Even if you start with some skepticism, it's okay, just do it and you'll learn along the way. And you have, as I said, passion. So what is the answer here? It's definitely infinite possibilities. You can do it. There is always another way. And when I actually started doing that, I gained more clarity. So all the publications that I published, they showed me the new directions of research. And I went back to my old grants and I refined them, I improved them, I came up with new ideas, and I submitted 2 grants, only 2, and these 2 got both accepted. So one of them was, as I mentioned, the Tubitak and the Marie Curie Fellowship, which is extremely competitive in the whole of Europe. Like, success rate is around 14%. So yeah, so that was the first part. Funding, rising with no funding, definitely possible. Now, the second part is research data. So as you guys know, we need data to, particularly in medicine and medical diagnosis, to train machine learning models in deep learning, fundamentally deep learning models. You need a lot of data. So at the time, I was thinking, okay, I need a lot of data. I need to train deep learning models, do medical image, whatever, segmentation, classification, diagnosis. I don't have GPUs. I don't have an NVIDIA station, for example, to use. How am I going to do that? So I thought maybe I can change the way I'm thinking about the problem. Maybe I can still do deep learning and I can still do, high level research, awesome research with limited data. So I thought, okay, for diagnosis, generally, we collect lots of data from hospitals. You have multi-source data. It's cool. It's awesome. It's wonderful, but I don't have access to that. So how am I gonna do it? So I came up with the concept of predictive intelligence in medicine, predicting data. So imagine, guys, wouldn't it be terrific if we can diagnose early and better with minimal resources or limited data and at lower costs? This is a dream for a clinician, for a researcher like myself. So this was the first question. And I was thinking, okay, maybe I cannot collect data. I don't have collaborators at the time. How about I try to predict data? So instead of basically collect less data, predict more data. So this was the principle that I was thinking about 2 years ago. And then when we predict data, we predict it along different dimensions. So For example, let's say when it comes to MRI, magnetic resonance imaging, we know that there is, the Alzheimer's disease data set, the ADNI, the ABIDE, you have functional data, you have diffusion data, diffusion MRI. So we have multimodal data. But for me, I just wanted to use a limited number of samples, like of basically one single sample or one single representation of the data. So I have the conventional T1 weighted MRI, which is traditionally acquired in hospitals. So this is like a basic scan routine, as in worldwide, I would say generally. And from this T1 weighted MRI, I wanted to work on brain connectivity because I was so mesmerized by the brain wiring. How is it working? The functional wiring, the neural wiring, etc. How our brain work, right? So here, we derived what we call the morphological brain network. So this morphological brain network, it encodes a morphological connectivity between two brain regions, and it's derived only from T1 weighted MRI. So having one of those representations, then what can we do? So from a single T1 weighted MRI, I can span or generate or predict data across domains. For example, functional MRI. I can generate functional from T1. I can generate functional connectivity or structural connectivity from morphological connectivity that is derived from T1 weighted MRI. I can also create high resolution data, generate high resolution data from low resolution. If the limited data that I have is very poor, of a poor quality, I can super resolve it. If it's at a single time point, I can foresee the future. I can do all the magic with the models that we develop. So this is basically what predictive intelligence is about in medicine, with application to medicine. And as I mentioned before, going back to the data, so this is about, all of our publications are focused on leading this direction in this field. So now I'm going to give you a lateral view of the BASIRA works or along these 3 dimensions in the last 2 years. So all of these works are available, most of them on GitHub and also YouTube channel. So let's start with the first dimension, predicting along, across domains. So for example, let's say we have a single graph here, you guys can see. And then from that single graph, it can represent morphological brain connectivity, limited data. And what we want to do, we want to learn a mapping. This mapping can be a geometric deep learning, graph neural network, any model that you can think of. And then we predict a target graph. And this target graph lives in the target domain where we have, for example, functional connectivity. So in this example, we're deriving functional connectivity for morphological one, okay? And later on, one of my students, Ella, she started working on multigraph prediction. So this is even cooler because now we can create a multigraph from a single graph. So we can predict graphs in multiple diverse target domains, structural connectivity, other morphological attributes, functional connectivity, etc. You can imagine it. So this is a generic concept. You can apply it to anything, but I project it to a network neuroscience. Now, when it comes to resolution, we also have introduced to the field of graph theory the concept of graphs super resolution. So I was like, before I started this, I was looking up, I tried to find any paper in the literature that has graph super resolution. And please, guys, if you do, let me know because I couldn't find it. And in 2019, we did the first work on introducing the concept of super resolving graphs. How do you create a high resolution graph from a low resolution graph? And this is really cool. Why is that? Because when it comes to brain networks, it takes a lot of pre-processing time to parcellate or partition the brain into different regions. And then you get, if you partition it into maybe 4 big lobes, for example, you get a low level connectivity. But what we wanted to do, we wanted to circumvent the need of the long processing time, data processing time, and registration, segmentation, parcellation, and directly predict the high resolution network. And this is what we did in several recent works, including MICAI and IPMI this year, IPMI. So aside from that, in addition to that, we also worked on brain graph evolution prediction. So from a single time point, we foresee the evolution of brain graphs. So this is one of the things I started working on during my postdoc with baby connectome evolution prediction, but it was more, at the time we used images and cortical surfaces, but here this is generalized to non-Euclidean spaces such as graphs. So next, there is another dimension here that permeates all these three dimensions: the domain, the time, and the resolution. And this is what we introduced to the graph integration, brain graph integration technique using geometric deep learning last Mikai. So we had basically a set of brain multigraphs. So these are different subjects. So we have, different subjects, and each subject is represented, each row is a brain, is a subject represented by multiple views, multi-view connectivity. So these can be thought as a multigraph. And then we tried to learn a model F that estimates what we called a connectional brain template. And this is like a roadmap of your brain. So it shows like a roadmap of a population of brain multigraphs. So why this is important? Because imagine you have a connectional brain template of a healthy brain, of a healthy population, and a disordered one, like with autism, for example. By simply comparing the two templates, you can easily spot out biomarkers. So it's a very easy way of comparing populations of different populations, healthy, disordered, and different types also of disorders. So now we have our models, our magic F models. We can predict, generate data. Now, once we generate that data, we can use the predicted data if it's reliable and trustworthy to do, for example, disease fingerprint prediction. So we can identify biomarkers. We can also do classification, use all that data to learn how to disentangle the healthy brain from the disordered brain. So there is a whole lot we can do with that. So now I'm going to give you just two examples very quickly, just to go a little bit deeper. So as I said, all of those are on YouTube and GitHub. Now let's look at this first paper published in Mikai, and it's currently under review at media. So Deep Graph Normalizer, a geometric deep learning approach for estimating connectional brain template. So this got accepted, this got an early accept last Mikai, and it was implemented by my student, Burak. He's an undergrad student. So the problem that we wanted to solve is this question, basically. How can we integrate a set of multi-view graph or multi-view graphs, okay, to estimate a connectional brain template for a population of brain networks? So this is the key idea. So we have different subjects. Each subject is represented by a different adjacency matrices that represent the graph connectivity matrices. So this is a tensor, also called a multigraph representation. And then we want to have our network, or our model right here, a multi-view integration model that generates a single matrix or a single graph called the connectional brain template. So how did we do that? So basically we used graph neural networks. First, for each subject was encoded. We learned the node-based representation of each brain graph, okay? So each brain multi-graph. And for that, we used what we call a convolutional networks. And particularly here, we used edge-based convolution. So after we learned the node embedding, so these V's are the nodes. So imagine here we have a 5x5 connectivity matrix, for example, because we have 5 nodes. So we learned the low dimensional embedding of the node, and then we derive the connectivity. We learn how to derive the edge weights from those node features. And after that, basically, you get the output CBT. So for that, we proposed a subject normalization loss. And this is basically primarily minimizing the Frobenius distance between the learned connectional brain template, the CBT, and a randomly selected subjects, randomly selected training subjects. Okay, so why we did the randomly selection? It showed that we can dramatically improve the performance because it's a way of regularizing your loss. So here, the key idea is that we want this template to be close to all these views and all the individuals in the population. So we want it to be centered, and this is why we propose this loss. So after that, for refinement, we did this for every single subject that we trained on. So we got what we call a subject-specific CBT, and then we performed a simple statistical operation, element-wise median. We computed the median across all subjects, and we got the refined population CBT. So in the results, we evaluated this on 2 data sets, the autism, AD-LMCI, Alzheimer's disease patients, and patients diagnosed with late mild cognitive impairment. And each subject was represented by 4 brain networks, as we had also the autism data versus normal controls, 310 subjects with 6 different views. So each subject was represented by a by a multigraph composed of 6 matrices. So in the centeredness evaluation, we found that DGN, the proposed model, outperformed a state-of-the-art model published in 2019, net norm, across 40 different comparisons. And we had also what we call a discriminativeness evaluation. We wanted to find the biomarkers by comparing the healthy CBT with, for example, the autistic CBT. We identify the features by computing a simple absolute difference. You take 2 matrices, A minus B, absolute value, take the elements with the highest, differences. These are your biomarkers. And then what we did, we took an independent machine learning model. We wanted to evaluate the reproducibility of our biomarkers. So we took an MKL, multiple kernel learning model. We vectorized all the data, did a typical feature selection, and we identified the biomarkers. Now, later on, we looked at the overlap in the identified biomarkers by the CBT, the DGN model, and by the MKL. And we found that actually our model, in comparison to state-of-the-art methods and other comparison methods, it has actually the highest reproducibility rate. So this was the first one glimpse of this work. Now I'm gonna give you a second one. So this is a sneak peek into the IPNI paper that will be presented this year. So this got selected as an oral presentation, and I'm gonna just give you an overview. So what is the problem that we're trying to solve? So the other dimension, it was the integration task. Now I'm gonna talk about the super resolution and cross-domain graph synthesis. So the question we wanted to solve here, how to predict intermodality non-isomorphic brain graphs from a base graph. So what is the idea? Simply put, you have a single brain graph, and from that brain graph, you want to generate multiple graphs in different modalities. Like, for example, for morphological, you get functional, but there is a change in the resolution. So generally, conventional works, we had what we call isomorphic graphs, which means the local neighborhood is preserved, and definitely we have the same number of nodes. And generally, the conventional models, they just use the same modality. So in the previous works, they use, for example, T1 weighted MRI to do cross-modality, cross-domain synthesis, but this is the same modality. But there isn't any work on cross-modalities, particularly with a shift in the resolution. What does that mean? It means that the input graph has NR nodes and the output graph has maybe more nodes, so NR prime nodes, and these two are different. So definitely these two graphs are non-isomorphic. So in that case, we thought, okay, so this is a source domain, and we have a target domain, and we want to learn how, if we give to our model here, the Iman graph net, we give it, for example, a base graph, we want to learn how to super resolve it in a different domain, in a different modality, like functional connectivity, resting state fMRI, for example. So the first idea was, okay, we want to learn how to align the data because these domains are very different. So we need to first align them. And after we align, we can generate. So for that, we designed an intermodality domain aligner. And we used for that the KL divergence as a loss between the source space, the source graphs, and the target graph. So first we moved or aligned the source graphs distribution to the target graph distribution. And we took the aligned, basically, graph distribution here, the aligned graphs, the output of the aligner network, we inputted into the non-isomorphic intermodality graph generator, and we used a graph GAN for that, generative adversarial network that we designed. So here, basically, step by step, we have a non-isomorphic generator where we're shifting the resolution right there. And we also have a discriminator that discriminates between the distribution, basically between the distribution of the target domain and the real target and the predicted ones. So this is basically the key idea of the proposed Iman graph net. We evaluated it on the SLIM data set, 300 subjects, 150 functional connectomes, and 150 morphological connectomes. The first ones are derived from resting stage fMRI, the second ones from the T1 weighted MRI. And we benchmarked against, for example, different variants, ablative versions. And also, for example, we use a simple statistical alignment right there. And you can see that in terms of MAE, the mean absolute error between the ground truth network and the predicted ones, the super resolved ones, we had the lowest error, and it was statistically significant using two-tailed pair t-test. And also in terms of clinical inspection, we compared the ground truth and the predicted ones, and we had really, how to say, reliable and biologically sound super resolved brain networks. So moving on next, we talked about funding. We talked about the data, we solved both. Now there is another thing, one last thing to share. It is so important to take initiatives and also join forces with great minds. So if I was able to do this, it's not just by myself, because you never rise alone. You rise with other people, with friends, with colleagues, with, you know, like, teachers who inspire you. And it's so important to also try to build your network, you know, talk to people, ask questions, try to create, you know, synergies, collaborations. It's very important to do that and have the will to rise and make the world fair with prime progress. And these are actually initiatives that I either started or co-led for over the last 2 years with friends of mine and colleagues and brilliant minds that inspired me. And we are trying to make an impact and real change through whether, you know, like organizing workshops like FAIR and Prime. Progress is promoting diversity in signal processing. This is, you know, part of ISIP conference. This is a new initiative that we're starting this year, reinforcing inclusiveness and diversity and empowering Mikai and low middle income countries. The Whale also is a new challenge. We'll be launching Women Inspirational Leadership and Legacy. So as I said, it's so important to dare to lead, dare to start things. Don't wait for someone just to call you in. If you have a passion, if you have an idea, just go for it. Now, the journey might be exhausting, tiring, long, but it is definitely memorable. I still remember the first time my students actually, they gave me, it was actually my first teaching award back in 2018. They surprised me with this gift and it really overwhelmed me. And I was overly excited. Like, I don't remember what I was saying, but basically, as you guys can see here, I was like, I was so excited, and like, you know, it was so heavy to carry that I put it on just that, like I put it there. So then, you know, along this journey, you also get surprises. Like, you know, like during my birthday, I scheduled a meeting with one of my students, and I was so surprised that all of them were there and they were singing me happy birthday. So there's always, you know, how do I say, always pays off. And you might get also bouquets on the International Women's Day. So I thank all my students, and I love all my students. I know sometimes I can be very strict and very bold, but it's for their own, how do I say, for what is best for them. That's at least what I believe. And I would say it's important to have, to feel that you belong with someone in your research as a human being, and also, you know, whatever you want to achieve, having that community is very important. So now moving up next, so the last thing I want to share is the mentorship program. So we're starting so we have this every year. We're starting a new mentorship program for mentors and mentees to join. And this would last for about 8 weeks. So last Mikai, for example, we had 12 papers accepted, and 7 of those students, you know, rising stars, they were undergrad students. So we usually have, for example, mentors supervising or co-supervising undergrad students. So we discuss things together, we talk about the idea, and we do things, we start with simple things and build complexity over time. And for example, Martin and like Ahmed, they're like mentoring, they're mentoring undergrad student right now. So if you are interested in joining as a mentor or as a mentee, there is a form. You just need to go to the BASIRA lab And the first thing you find on the page is, apply now. So if you click there on the link, it will get you to a Google form that you can fill out and apply. And also there is this barcode that you can scan and find the link directly. So start now, empower others, and remember that the road will always rise up to meet you. And most importantly, one last thing to say, we never rise alone. We always rise together. So thank you everyone for joining the meeting today. So I want to share a heartfelt thank you to all my loved ones, my teachers, my students, my collaborators, and anyone who inspired me in books or in person. And thank you all wherever you are. And that's it. So thanks, guys. I'm going to stop the sharing.
Thank you very much for that. It was very, very interesting talk.
Thank you, Liam.
Open up for questions in a second. I think the thing with the mentorship program and what you said about limited data is something that's really interesting. And I think particularly nowadays with things like Google Colab, it's almost feasible to do a full project or at least proof of concept just with public data sets like BRATS, ADNI, whatever it might be, and just running it on Colab with a GPU.
Absolutely. So that's what when I started with my students, I told them, guys, Colab, just go for it. Yeah.
I think I know of as well. I don't want to take away from the mentorship program and advertise competitors, but there's another one I know of in the US, more focused for just standard AI.
Oh, really?
Actually called the Fatima Fellowship.
All right, cool. I would love to learn about these programs. It's so nice. I think whenever you see a good model, you always try to replicate wherever you are, and it's really good because when you're replicating, you're reaching out to your also local network, and you're trying to help and inspire wherever you are. So definitely, I would love to. So yeah, so I think there are like few mentorship programs, and they are just proliferating at an incredible pace right now. This is the time, especially due to the pandemic. Like it kind of opened up new ways of thinking about research and rethinking about supervising and learning and mentoring and being a mentee also and a learner. So there's actually no boundary if you have a good internet connection and you have a good laptop. As an engineer, the good thing, you can carry your work with you wherever you are. So it's very flexible.
Absolutely, yeah. I think that's the beautiful thing about it is how it is now. You could be in the US and mentor a student anywhere in the world, in Palestine, in Morocco,
Definitely.
or wherever they might be. I think it definitely opens up a lot of doors. I think something leading on to that I was wondering is in terms of clinical collaborations.
Yes.
Do you think that having this has helped for having this more remotely? I guess it leads on to the things with Prime and Fair maybe with at the moment, if all of the data you're training on is just from the US or Europe,
Definitely.
it's hard to translate this.
So you hit the spot right there, man. So I'm going to tell you, so this is one thing that I'm really interested in, like, building cross continent or within, national collaboration. So I haven't gotten the, how do I say, to that yet, but it's been on my mind for a while. Getting the data, that would be awesome. It's particularly working with clinicians on new problems, or like having clinical messed up data, because I know, for example, I'm just talking about Tunisia, like when they acquire MRI, they don't acquire it in 3D directly. So basically they have the sagittal view, the coronal view, and the actual, completely separate. So you don't, it's very, how do I say, the acquisition protocols, they vary a lot. The data varies a lot. So I think this is where the future is heading, particularly with federated learning and all, explainable in AI and interpretable AI. So this is one of the milestones that I'm hoping to hit during this year, setting up international collaborations and particularly getting new data to work on. However, one thing is there's a lot of sometimes constrictions about data sharing, but if we find a safe way of doing it and everything is follows up the protocols properly, definitely I'm up for it. So if you have data, just drop me an email, or someone who got data, that's fine. I'm open to work on new problems. and collaborating. Thanks everyone for your feedback. I'm reading. Oh, thank you guys. Thanks everyone.
If anyone
Any
else has any
questions at
questions.
all? It's like, if you guys have any questions, please feel free, like, whatever question crosses your mind, just shoot. Yeah, so Liam, you were saying something.
I was going to say the exact same you said just then, just if anyone has any questions, just feel free to unmute yourself. But
So
I think, yeah, with this, I think, like you said, with federated learning, I think this seems like something that really could make this more feasible.
right.
One less hurdle to overcome, I guess.
Mm-hmm. So, so what do you guys primarily work on? Like the attendees here, like for example at UCL, like what are the big topics or the main themes? I know a lot, maybe.
As the society or
Oh no,
as a university?
as a group in, like, and university, for example, as a group, your research group, for example, what are the things that you primarily work on? I mean, the problem is, like, if you guys don't ask the questions, I'm gonna be the one asking the questions. Okay, yeah.
I think, I mean, at UCL, I think there's quite a lot of different things. For me personally,
Yeah.
my research is with strokes.
Mm-hmm.
So the work I'm doing is with, I think you mentioned it in the talk, stroke lesion segmentation.
Yeah, I did my PhD on stroke. It was like
Okay.
so challenging. I remember, like, I worked on a perfusion and diffusion MRI, and I wanted to do predictive modeling. So basically, if you have, an acute stroke image, you want to foresee the evolution until, after a few months. And it was extremely difficult. So I ended up, doing dynamic modeling, but without prediction. Currently, I am not aware of any, maybe you know best, but I'm not following up the literature a lot since then, but I'm not aware of a predictive, like a lesion prediction model, like for example, in terms of across both modalities, perfusion and diffusion, like you're trying to foresee the evolution, not just quantify, but you're having different patients with different types of stroke lesions, and still you can predict the evolution of that lesion accurately. Like, I'm not aware. So this is like a cool research direction. If you have longitudinal data, that would be so cool to explore.
Absolutely, yeah. We have quite a big team for UCL. It's the PLORAS, predicting lesion, language outcome and recovery after stroke.
Oh, the outcome. So what I meant by lesion is not the outcome. It's not, the recovery. It's not the rate. It's the whole image. So for example, you're predicting generating the MRI, the diffusion MRI. So for example, outcomes, I've seen like lots of works around that, like on that. You have like an MRI and you try to just map your linear model, and you have two values or three. So it's like a classification or a simple regression, but generating data from data, like for example, diffusion
Okay, yeah.
MRI T1, and you create a whole diffusion MRI T2, right, at later a second time point. So that kind of work, I'm not I haven't seen so far, to the best of my knowledge, as we say always.
No, I don't think I have either. So
Yeah, so but that is so cool to do, because I'm sure it's gonna, if you can predict the future, you can also predict better the outcomes. So we have a few questions here. Shall I go and read them? So there is like a first question, direct message. Okay, so what life advice would you give to your younger self and your students? And how do you deal with setbacks? So very excellent question. So my younger self, what should I say to my young? So actually, what I want to say to my younger self, I say to my students right now, and I say to my undergrad students. So, for example, I gave a talk like last semester to first year freshmen, computer scientists, computer engineers here at ITU, and the first thing I told them, guys, no one has taught me this, but I want you to know this. First thing, document your journey, create a GitHub, get a LinkedIn, everything, every day you learn something, share it with the world, because if you learn for yourself alone, it will just, information will fly away. But if you learn for the other, for other people, you want to share benefit, someone, then it will stick there in your brain somehow. And also you will have a track record of whatever you're publishing. So you can have a Twitter account, for example. If you learn about graph theory, put your first, graph algorithm there. So just try to have fun learning. And when you go back every day or every week, you do one single thing. After a year, 365 days, you're going to see, oh, I have done a whole lot, just by having this little tweet or this little thing that I'm doing on a weekly basis or monthly, or maybe you can do it daily basis. It depends on you. So documenting yourself, documenting your journey, keeping track of, how do I say, what you're doing, creating your domain, for example, on LinkedIn and GitHub, so important. I know all of us don't have a lot of time, but if you are into YouTube and you want to share a few things here and there. So for example, recently I started creating trailers for research papers, just I draw on my iPad. I'm not really an expert. If I had more time, I would be just probably an artist. So I love creating things and music and all that stuff. So anyway, so creating trailers, I try to explain an idea in just 30 seconds. So you can do something that maybe for that for your paper. So there is a whole lot that you can do. And I would say also, so this is what I tell my students, but also to my younger self, what if I this is a very good question. I need to think a little bit. Is there anything I want to say to my younger self? I think overall, my journey hasn't been difficult. I mean, all of us, we get stressed, we get these dips. But the good thing, I think I don't stay low for a long time. It's just 1 hour, and then I get over it. So basically, I remember when all of us get paid, we got once or maybe more, at least many times myself, papers rejected. So the moment I get a paper rejected, I don't feel low, and I say, okay, now my paper got rejected. No, I just move on to the next step where I'm going to submit it. I submit it the next day or after 2 days. I revise and resubmit. So I don't overthink about that. So basically, I act. I'm constantly on the go, playing the game. So you don't need to actually, spend a lot of time feeling low, because if feeling low actually helps, just do it all the time. It does not, right? So you need to just, think and reason and act immediately. Yeah. So now, how to deal with setbacks. So setbacks, it's okay. I mean, you just take your time to digest, think. And what I do, I take time to disconnect. I think it's so important. For me, if I feel something is so overwhelming and something, that is really challenging me or unexpected, that disappointed me has happened. So I take time to disconnect and think, go outside, whether journal, think, reflect, and have my me time to think things through. And I think having that reflection, we say a reflection of 1 hour is worth a worship of thousands of years. So reflection and thinking is so important, and that helped me a lot in my journey, particularly with setbacks. After thinking, you come up with a plan, and you need to be prepared, and you need to see how you're going to do it, how you're going to solve it. So you think it through, becomes clearer, and also get asking people. So setbacks, I never navigate troubles or challenges alone. So this is what I said about rising. We never rise alone. So I have my own support networks, my best friends, my family. I talk to them, my colleagues, I go to them, I say, okay, I have this problem, this happened to me, or this something, I show them, and they give you feedback, and you trust their opinions, and it's good to have that support network. So don't be alone in your struggles. So it's important to have someone also by your side. And the challenges never end. And I always thought that after my postdoc, it's gonna get easier. So I'm gonna just relax, and enjoy my time and have fun. Now I have students, but it actually always gets more challenging. It takes more of your time. So as you go up the ladder, it gets more, I would say stressful. So you need to learn how to handle your stress, and having a time off, for example, a whole day off, or when you go back home, you don't do anything. So I remember during my postdoc, I go back home, I don't do anything, literally. I read, I don't do anything related to work, what I mean. So, and also I take the weekend off, or maybe at least, you know, one whole day off. And that improved my productivity. And during my PhD in Edinburgh, I did so many things. I had a lot of fun, you know, cycling, book reading, you know, radio shows, every single thing. And I was really also, I was, you know, I think my PhD went very well. I finished it in 3 years, 4 publications, went to Australia, Hawaii, you know, it was really cool. So yeah, so that was the first question. Now let's look at the other questions. Thank you so much. I'm not sure how to pronounce your name. So we had Faye and then Kylie. Is it Kylie? Am I pronouncing correctly? From the chat. Okay. So yes, thanks. So thanks for attending. So since this is part of the Women in MedTech series, I was just wondering if you could share a bit more specifically about your experience as a woman in this field. That is an excellent question. So so far, I would say so good. Honestly, like, you know, although I came up, how do we say, from you know, a low middle income country. I grew up in Tunisia. I'm like, you know, if you guys can see, I'm like, you know, there's a lot of framing and about Muslims almost everywhere. So, but I never had a problem. So for me, I'm like, I would say I never felt there was a bias against me, that there is, you know, I always felt supported, loved by my supervisors, colleagues, you know. So I think if you are generally, and also I don't know why, this something happened to me. I never thought about this problem, men and women. I always thought about myself as a researcher. So I never dichotomized and I never categorized. So whenever I applied for a job, I never thought about, oh, you know, they're gonna be, maybe they will prefer someone, you know, from the opposite gender or whatever. So I never had that thought in mind. When did I learn this? I learned this when I joined the Mikai community. You know, like recently, not recently. I mean, like when I become the president of the Women in Mikai, and I knew that there is actually a bias out there. So there are women who are struggling. There are female researchers who are extremely struggling, and I wasn't one of them. But I can relate to them, and I'm highly supportive, and we're trying to find ways around and like to you know, empower women and also support them. And I think when it comes particularly, for example, to you know, building a family, having maternity leave, it's a huge, there is a lot of unfairness around there, that, you know, universities, they need to support in their policies, you know, women to have maternity leave, but also in terms of productivity, you know, not to judge them in terms of recruitment and, you know, like upgrading also and all of that stuff. So there's a lot to discuss, but I think you should always speak up for yourself. Like, I never stood up for myself. Like, if I feel something is unfair, I can write a letter to the rector. I don't care. I say my word. I am reasonable. I'm not emotional, and I reason about it. So I think you need to really be true to who you are, whoever you are, and stand up to your own values. And that's it. So do your best doing that. Thanks, Suru. So another question, Manat. Thank you so much. So you mentioned lots of books throughout your talk. What are the top 3 books that have shaped, impacted your life? Oh my goodness. Oh, this is so difficult. How I'm gonna get to that question. Many books, but the first one I mentioned is the Quran, it's the holy book, but I'm gonna exclude that. So I'm gonna talk about other books, human books. So the first one, there's so many. Number 1, The Brain That Changes, The Brain That Changes Itself by Norman Dwutch. So I'm gonna write it here. So I will put the list. So The Brain That Changes Itself by Norman Dwutch, or Deutsch in Canada. It's a great read, and I recommend it for every single human being. It's a lay level neuroscience, but it inspires you about, it just tells you how your brain is so awesome. It's more awesome than the whole universe. And there's a lot of storytelling in it. I love the book. It talks about neuroplasticity a lot, which I really love, how your brain changes constantly. Now, the second book is, I think, Make It Stick. That was a great read, the one I recommended. These are the books I remember now. There are like so many books. There is another book, let me remember. So these two, oh, there was the also The Power of Intention, Chopra. That was a great book I read also, because intention is so important. Like I tell students, for example, if you start reading a paper, like for example, if you start attending a journal club, okay, taking notes just for your own self, just for your own research, your brain will react in a particular way. Now, if you have the intention that you're gonna attend exactly the same talk, take notes, but you're gonna build a lab later on, or you're gonna teach students, or you're gonna share it with the world, or you're gonna, create lots of projects, lots of ideas for your own projects from just one single talk, you're going to do a whole lot. So intention is extremely, extremely important. So The Power of Intention. And there are so many books, but these are the top 3 that come right now to my mind. Now, another question. Hajer, so thank you so much. So I'm affiliated with Imperial College London, and I was wondering what mentorship you had in place with the uni, and what kind of collabs you had, which labs, department. Also, are you planning on having any PhD openings soon? Isaac, okay, thank you. So the mentorship I have is there is no co-mentorship. So when I say mentorship, you just volunteer. So you're going to do this as a side project. So for now, there isn't a, how do I say, an official mentorship program. So when I started my lab, I started it virtually. It was just, floating around. It was global. So the mentorship program is like you can say it like, it's like something you can volunteer, like you can join, and you can do it as a side project just in your free time. And I said for mentors, for example, it just takes a maximum 1 hour per week, usually half an hour. For mentees, it varies between 3 hours to 1 day, depending on the kind of project you want to develop, okay, and the kind of work you want to publish. So depending on that, when you fill out the form, you will see there are different things to tick, and depending on what you tick and all, and your skills, etc. So there is a selection process, because we get lots of applications, and this is all based on volunteering and just collaborating, international collaboration. So just look at the form. So there isn't anything official. It's just a freelancing type, I would say. Planning on having any PhD openings soon. I actually do right now. So I have a few openings. I have a few openings right now for PhD studentships. So if you're interested, feel free to drop me your email. Now, Muntasar, based on your experience, one of my students, based on your experience, how can a person manage his time to achieve multiple goals? That's one of the biggest questions. So you need to prioritize. Thank you. You need to prioritization. So sometimes you feel that you get really overwhelmed. You want to learn about everything at the same time, but you don't have the time to do all of that. So you need to break down your goals and whatever you want to achieve into workable actions and into a workable plan. And to do that, basically, I think the first thing you need to prioritize, what is it exactly that you want to learn? And how can you know that? That's even a more difficult question, because sometimes you don't know how to prioritize as a student, as a learner. You're coming or walking into a new field, and it's an uncharted territory, so you don't know how to navigate it. So I would say, if you ask, supervisor, or maybe you can find books. I always try to find books to guide me. I want to learn writing. I looked for the best writing books. I want to learn time management and project development. I looked into that. Now I'm interested into startups. So I started reading the It Will Never Work. It Will Never Work, the Netflix story. And it was a great read, by the way. I should have mentioned that. That was number 4, but I just finished it recently. So so basically what I'm saying is, when it comes to time management and you want to learn so many things, you need to make a plan. So have a plan. I have a plan for my 2021. See? So it's important, and I always have my plan in front of me. So have a plan, say, in this month, I'm going to, for example, learn about, I don't know, convolution neural networks. Set your deadlines and your deliverables. If you set your deadlines and you articulate your deliverables, the outcome of your learning experience, then you can easily move from one little thing to another thing, etc. So you don't need to do so many things at the same time. Maybe 2 or 3, you can juggle them. But if you do more, then you might get overwhelmed and get lost in the details. And you don't want to get really lost in the details. So you learn that with time, and maybe you need someone to how do I say, maybe I don't know if there is an app or there is something that can help you manage. I'm sure there are many time management apps and all of that, so you can learn how to do that. So start with many things, something small, do it, and celebrate every time you time you achieve one thing. Celebrate. And I do that every time I finish a conference deadline. We're done. I just go on a trip for 3 days, disconnect. So, and this is probably not many times, twice a year or something. So I think it's so important to basically have a reward system, because the brain works, it's like it's like reinforcement learning. It's also inspired from how the brain works. Whenever you basically give a reward to your brain, it gets more excited and it wants to do more, and you feel that you're going in the right direction. So I hope that helped a bit, but this is a very difficult question indeed. Any other questions, guys? Okay, so I guess that's it then. I have time if you guys, yeah, it's actually 9:25, like half an hour, I'm gonna go to bed. Okay, yeah, about top medical imaging journals. Simon, right? So top medical imaging journals. So you need to look at the impact factor. Okay, so I'm just going to say my rule, but the rule varies from groups to groups, from teams to teams. But for me, the lowest impact, which is really good in our field, it's good, 2.5. So I don't publish in lower than 2.5. So I would say for the medical imaging journals, there is TMI, Transactions on Medical Imaging. There is Medical Image Analysis. There is also NeuroImage. There are other, it depends on what you work. If you work on cardiac data, or you work on neuro data, so these are different. So you can just, for example, Google that, type top medical image analysis journals, and you can find a list. I'm sure there are lots of, you can find that easily on Google, and then you look at the impact and you can discover the best journals in your field, particularly. So that's one way. Another way is to follow the top leaders, international leaders in the field, who publish in high impact journals, and they're like really good. So I always, for example, follow the senior researchers. Where are they publishing their papers? And I just target those journals. So that's also another way of, finding the best journals to submit to. Should I write a novel method or only new contributions? I mean, about medical image analysis, for example. Very good question. Okay. So I review and also submit a lot to medical image analysis. So for medical image analysis, it's an extension of MICAI papers generally. So the medical image analysis journal started as a, it's just, it started from MICAI, it came out of MICAI society in the conference. So many of the medical image analysis media papers, there are extensions of MICAI papers. So for myself, I think it's important to have at least, so when you want to, it depends. So if your paper is an extension of your MICAI, I think it's important to have at least one methodological contribution. So you benchmark against your own MICAI, and maybe you can add more data sets. And also definitely you're going to add, in-depth discussion, longer, introduction, and lots of plots. Okay. But having a technical contribution, it makes your submission stronger, okay? Even if your paper was accepted as a MICAI, okay? Now, if you are submitting a new paper that you haven't submitted before, everything is new, I think you should definitely have strong methodological contributions, which means you have benchmarked against state-of-the-art method, technical methods, okay? Like architectures in terms of CNN, if you're using GAN, I don't know, you're creating new variants, new losses, new training strategies, whatever you're doing, student-teacher network, for example, few-shot learning, whatever you're doing, you really need to benchmark against state-of-the-art methods. So, or the variants and the updated versions of your method. So if your paper is just incremental, so you took a model and you changed a tiny, teeny thing, okay, so maybe just tweak the loss, that's it, you're done, and you applied it to a new data set, for me, that's not a media paper, that's more like neuroimage clinical paper maybe, or you can maybe submit it to a clinical, like, you know, I don't know, frontiers in neuroscience or something like that. So, but for media, primarily it's technical. Also TMI, IEEE, that is also highly technical. So you need to have generic contributions, which means when you are submitting your paper, someone else can get inspired from your model and use it for a different application. So it's not just for, you know, it's a bit, it's generic. So you can think about it as, you know, a translation of the NeurIPS papers or TPAMI papers into, you know, the medical field. Yeah. Any other questions? Okay.
I think that'll probably be it then. Thank you very much for joining us. Really, really
Thank you so
interesting
much
topic.
for
I enjoyed it a
inviting me.
lot.
It's been wonderful. And I wish everyone the very best. And yeah, thanks for attending today. Take care, everyone. Thank you. Bye-bye.
Thank you.
Thanks.